Everyone thinks the magic is in the model. We obsess over model parameter. We assume that the path to true digital autonomy is just a bigger, smarter, multi-model brain. But we are looking at the wrong hemisphere by entirely focusing on raw cognitive scaling part. The real revolution isn't only happening inside the model, it's also happening around it. Because no matter how many trillions of tokens the model was trained on, it cannot write software, it cannot ship a feature, it cannot debug a production outage. To turn this brain into an autonomous software engineer, you would need something entirely different. Welcome to Tech Dive, and let's dive into today's topic of AI harness. To understand why this architecture is mandatory, we have to look back at how we got here. For quite some time now, we lived in the era of single shot prompt, the API wrapper. You gave an LLM a string of characters, it predicted the next token, and you iterate it over to generate a meaningful response. We call this prompt engineering. We spent countless hours crafting perfect markdown templates, adding system instructions, hoping the model would perform better using our tips. A raw language model has its own limitations. Firstly, it is stateless. It has no memory of what we did just 5 minutes ago, unless you feed its entire history back into it, consuming a massive amount of context. Secondly, it is non-deterministic. It's sort of a guesser, guessing the next token. If it hits the unexpected error or an edge case syntax failure, it cannot self-correct. It just hallucinates. Third, it is unsafe. It has no concept of permissions, the system boundaries, or destructive actions. It will happily output a command to reach the database, and there have been instances where this had happened in the past. Lastly, it is entirely disconnected from reality. It does not know what a file system is. It can't run npm test. It can't look at the Git history. Here is the core idea now. Earlier, it was solely based upon prompts. Better prompt will give better AI results. Now there's a shift towards better system around AI gives better AI results. Models are the brain, there is no doubt about that. Harnesses are the operating system around that brain. Think about computer hardware, a modern silicon CPU, which is capable of executing billions of calculations per second. But if you boot up a bare metal machine without an operating system, that CPU is useless. It does not know how to schedule a thread. It has no concept of network sockets or user permissions. The operating system is the harness that transforms raw silicon computing into a predictable, stable runtime environment. A AI harness does the exact same thing for the large language model. Models provide the raw, high-level cognitive capability, but the harnesses provide the state, the tool, the memory boundaries, the verification loops, and the operational semantics. I'm sure you all have used Cursor, Codex, Cloud Code. When you see an advanced AI agent pull down a repo, find a bug, rewrite a module, run a test suite, fix its own errors, push a clean pull request, you aren't watching a smart model. You are watching a highly engineered harness orchestrating that model. Let's look under the hood what actually inside an AI harness. First, context management. A raw model will drown if you drop a million line repository into its window. The harness acts as intelligent router. It uses vector search, abstract syntax tree analysis, dependency graphs to prune the code down, injecting only the exact functions, the files the model needs into its immediate prompt context. Second, tool dispatch and the MCP. Model can't talk to internet or run shell scripts directly. The harness intercepts tool calls. When a tool like Claude Code decides it to view a file, it outputs a structured JSON block. The harness catches this, validates it, executes the command on the native host machine, and pipes the output back to the model. Third, memory systems. The harness implements a multi-tier storage layout. It maintains a short-term, ephemeral context of the current loop, episodic memory of the past attempts within the session, and long-term semantic memory stored in the external databases so that agent remembers the project-specific preferences across multiple days. Fourth, permissions and guardrails. The harness is the security parameter. It parses the commands generated by the model before they hit the terminal. If the model attempts to run an unapproved command or access directory out of scope, the harness blocks it, sanitizes the state, and forces a course correction. Fifth, verification loops. When an agent edits a file, the harness doesn't just trust that. It may spin automated linters, compilers, test runners. If a test suite fails, the harness captures the exact stack trace, attaches it to the new event loop, and tells the model to fix it. Finally, the harness handle lifecycle hooks, observability tracing, planning engine, sub-agent coordination, secure sandboxing. It ensures that if the agent spins out of control, it is safely isolated in virtual environment. The industry is waking up to an uncomfortable truth of AI providers. Models are rapidly becoming commodities. Whether you're using OpenAI, Anthropic, Gemini, the cognitive baseline capabilities are going to converge on a similar plateau. The raw intelligence is becoming a metered utility. Therefore, your core intellectual property, your product defensibility, your engineering edge is no longer the model you use. It's the harness you build around it. That's why the platforms like Cursor's Claude Code feels magical. It's not because they have access to a secret version of LLM that you don't. It's because their engineering teams spend months perfecting the harness infrastructure, ensuring the system catches the errors before you see them, builds accurate context maps of your workspace, and handle the system failures gracefully. The magic isn't the model. The magic is the system around it, the AI harness.